Alright, welcome. In this video I'm going to be working the Algebra 2 Unit 8 review, which is all about radicals and radical functions. And this is one that, obviously you're going to need to do on a separate sheet of paper, so let me just get one of those. Alright, so let's get to it. We're just going to start by writing these as a rational power of 10. Okay, so, I'm going to say, okay, I've got 10 to the 5. The square root of that, that's 1/2 power. We know our exponent rules that, so we're going to multiply the exponents, and that's going to be 10 to the 5 times a half is 5 halves. Or you could look at it as, this is the numerator, index of the radical is the denominator. Okay, for b, this is the 4th root of 10, that's 10 to the 1/4, taken to the 9th power. Again, I'm going to multiply the exponents, that's not 19, it's going to be 10 to the 9/4, so it's 10 to the 9. Okay, 1 over the cube root of 10 is the cube root of 10 to the negative 1st power. Okay, and the cube root of 10 is 10 to the 1/3. So that would be 10 to the negative 1/3. And then with this one, okay, if I've got square root of 10, cube root of 10, that's 10 to the 1/2 times 10 to the 1/3. Okay, this is a situation where we're multiplying two things with the same base and different exponents. We'll add the exponents. This will be 10 to the 1/2 plus 1/3. 1/2 plus 1/3, that's 5/6. You look at it, 3/6 plus 2/6. Either way, it's going to be 10 to the 5/6. All right, now we've got the 3rd root of 10 to the 5th. All right, this is going to be a little more involved. So I'm going to call that 10 to the 5/3. Divided by the 4th root of 10, so that would be 10 to the 1/4. Now when we're dividing two things with the same base and different exponents, we're going to subtract the exponents. So it's going to be 10 to the 5/3 minus 1/4. And that's going to involve some fraction arithmetic that I don't know that I have just mentally. Maybe I could if I just really tried, but let me go off to the side. Say, all right. We're going to need to go for 12ths. That'll be a common denominator between 3 and 4. So 5/3 would be 20 over 4. No, wait, 20 over 12. Pardon me. Multiplying by 4 over 4 here, multiplying by 3 over 3 here. That'll be 3 over 12. Okay, so it'll be 17 over 12. F, we're going to take the cube root of the 5th root of 10. And if you can already see what this is and you don't need to write out the steps, that's fine. I'm just, in case somebody was not, immediately seeing what to do here, I'm just going to show you a way we could attack this. You can kind of start from the inside. The 5th root is 10 to the 1/5 power, and we're going to take the cube root of that. But really, the cube root is just the 1/3 power. And so we're going to multiply exponents. So 1/5 times 1/3, we multiply across 1 over 15. And then the last one, 10 to the 3rd divided by 10 to the 1/3. So that would be 10 to the 3 minus 1/3. I'd really prefer that you don't call this 2 2/3, but if you have to, I guess it's not the end of the world. Let's say 3 is 9/3 minus 1/3 would be 8/3. The reason I don't want you to do mixed numbers is we're kind of gearing up for a test that's at least partially multiple choice, and I can promise you that there won't be any answer choices that have mixed numbers as an exponent. That's just not going to happen. Okay, so that's number one, writing a number as a rational. All right, now let's write some expressions in simplified radical form. So remember, that's going to be no unsimplified radicals and no radicals in the denominator. Okay, so starting off with the cube root of 7/2. So I'm going to write that as the cube root of 7 divided by the cube root of 2. And, okay, the issue with this is not like an unreduced radical, it's the fact that I've got a radical in the denominator. So I'm going to be multiplying by a clever form of 1, just the right form of 1 that will get this to be not a radical. So I'm going to cube roots of 2 in order to make 2, so I'm going to say I need 2 more. And to be fair to the fraction, not change it, I need to multiply by 1, so I'm going to multiply that same thing on top and bottom. Okay, and then, down here I've got 3 copies of the cube root of 2, that'll be 2. And then well, cube root of 7, cube root of 2, cube root of 2, there's not going to be really anything I can do with that. So what I could do is I could combine them into one cube root. So 7 times 2 is 14, 14 times 2 is 28, and I've got a cube root of 28. B, okay, this one's interesting, 5 root 13 times 4 root 26. What I'm seeing is I'm seeing 13 and that 26, and like maybe we could combine those and, you know, get something free of the square root. But what I'm not going to do is I'm not going to try to figure out what 13 times 26 is. Right? We probably could if we really tried hard, but it's not going to be the way to go. So we're going to want to eventually split that number into factors, and so we might as well just leave it split into factors. So I'm going to put the 5 and 4 together, and then I'm going to say, all right, square root of 13. But then I'm going to actually take the 26 and I'm going to split that into 13 and 2. And then that's going to make 13, right? Square root of 13, square root of 13, that's just 13. And so that's going to be 20 times 13 times the square root of 2. 13 times 2 is 26, so 13 times 20 would be 260 root 2. All right, the next one is the 4th root of 81, a to the 12, b to the 20. So I'm going to split this up into the 4th root of each of these things multiplied together because I'm hopeful about the possibility of taking the 4th root of 81, the 4th root of a to the 12, and the 4th root of b to the 20. Okay, and I'm going to say, all right, well, 4th root of 81, okay, maybe by this point you're remembering that's 3. If not, take the square root twice. Square root of 81 is 9, square root of 9 is 3. Okay, the 4th root of a to the 12, the 4th root really divides the power by 4, so a to the 12 over 4 is a cubed. And then b to the 20 divided by 4 would be b to the 5. And I mean, I didn't put the disclaimer on there, but I think, you know, in this unit, I think I told y'all you can just always assume these variables are positive, so we don't need to worry about the fact that the 4th root of b to the 20 is the absolute value of b to the 5. No one cares about that. It's not what we're talking about here. We're not really solving equations. And when we solve equations, we know what to do then. We know that when we take the square root of both sides, we need to bring in a plus minus. We know that we need to check our answer when we square both sides of an equation, you know, all that stuff that we've learned about in this unit. Okay, so let's do part D. It's going to be the 5th root of negative 32x to the 8. Okay, so I'm going to do the same thing with this one. I'm going to start with the 5th root of negative 32. Which, that's fine, that's no big deal, right? If we can take the 5th root of a negative number, it's just going to come back negative. And then we're going to multiply by the 5th root of negative 8. Wait, no. Just thinking about too many 5th roots of negative numbers. This is going to be the 5th root of x. All right, so the 5th root of negative 32, well, I mean, you can just say, okay, the 5th root of a negative number is going to be negative. And the 5th root of 32 is going to be 2 because 2 to the 5 is 32. And the 5th root of x to the 8, well, I'm going to call that x to the 8/5. Because that's the thing I really want you to be fluent in, is writing that as a rational exponent. But I should also point out that, like, in a multiple choice environment, you might not write it like this, right? They might say, hey, this is x to the 5/5 plus 3 more fifths. So you need to recognize that this number is the exact same as negative 2x times the 5th root of x cubed, right? So that would be 5/5 and 3 more fifths adding together to be 8/5, right? So just as long as we're recognizing that these are the same number, we're going to be good on an assessment level because, like, in an open response scenario, I'm cool with either of these. All right. But that's my class. Okay, so might not apply to your class if you're not in my class. All right, so 1 over 2 plus the square root of 5. Okay, we've got a radical in the denominator. And this is one we haven't really run into in a while. We're going to need to multiply by the conjugate of the radical on top and bottom. So I'm going to multiply by 2 minus root 5 over 2 minus root 5. And on the top, I'll have 2 minus the square root of 5. And on the bottom, I'm going to have to do some voids. So I'm going to have 2 times 2 is 4, minus 2 root 5, plus 2 root 5. And then over here, I'll have minus root 5 times root 5 is minus 5. All right, so just like always, these two are going to kind of add to 0. and I'll have 2 minus root 5 over negative 1 is going to be negative 2 plus the square root of 5, right? Because dividing by negative 1 is the same as multiplying by negative 1. Right, and the last one is kind of the same, but it's got, you know, one of these more interesting radical expressions on top, so I have sorts of stuff going on here. 1 minus the square root of 6. Oh, I actually do like where this is going, because we're going to actually have to reduce a radical as well. Okay, so I'm going to multiply by the conjugate of the denominator, so 1 plus the square root of 6 over 1 plus the square root of 6. Maybe I'll do the FOIL on bottom this time, since I've got 2 FOILings coming my way. All right, but since I just did that, I know what's going to happen with the inside and the outside terms. I'm going to have negative root 6 plus root 6, and that's going to go 0. So I'll have 1 times 1 minus root 6 times root 6. And then over here, I'm going to do 2 times 1, 2 times root 6, minus 1 times root 3, minus the square root of 18, because the square root of 6 times the square root of 3, that would be the square root of 18. And, okay, whereas root 6 and root 3, these are not things that I'm going to be able to work with. I do think, yeah, I've got a factor of 9 in here, so I should be able to do something with that. All right, so this is 2 plus 2 root 6 minus root 3, and then 18 being 9 times 2, root 9, times root 2, all divided by negative 5. And I'm going to just double check this, but I don't think there's really anything I could do to simplify this further, right? I don't have any, you know, unsimplified fractions, no unreduced radicals, and no radicals in the denominator. So this one was like a little bit of a wild ride, but just gotta say, I'd rate a situation like this as extremely unlikely on your upcoming test. Probably not something you're going to be tested on. All right, now let's do some graphing. Now this is going to be a little more intensive. So we're going to find the domain and range, x and y-intercept, and a sketch of the graph for all of these. And I do think, I was a little worried about these before I started recording. I was like, did I put enough graphs on there that had enough interestingness to represent what you're going to have to do on the test? I think that'll be good, and I think maybe I'll go back and look at the test, and if there's any that I didn't hit already, then I'll come back and just add a G or something. All right, so part A. F of x is the negative square root of x minus 3 plus 5. Okay. Let's just start with domain. All right. With the domain, we grab the radicand, and we set it greater than or equal to 0. Okay, so that's, and I'm going to solve for x. That's x is greater than or equal to 3. The range. Okay. The thing that we always need to remember is that the square root thing, the square root of x plus 3, is greater than or equal to 0 also, okay, because it's the positive square root. So that means that we've got 5 minus at least 0. Okay, so if that worked for you, then you're like, oh, okay, 5 minus at least 0 is everything less than 5 or equal to 5. Or you could actually just like keep working on this range, starting always with the fact that the square root is positive or greater than or equal to 0. And then we could just say, okay, well, if I multiplied it by negative 1, that would reverse the direction of the inequality. I'd keep putting plus, but that's not true. It's supposed to be a minus here. I'll go back and fix that in a second. And then I'm going to add 5. Wait. I'm really messing that up here. Yeah, I just multiplied by negative 1, so that would just reverse the direction of the inequality. And I'll add 5. And we get y less than or equal to 5. Okay, so if you want to work through it algebraically, that's how you do that. But if you just want to say, okay, it's 5 minus at least 0, that works too. All right, domain and range, x-intercept, y-intercept, sketch the graph. Okay, for the x-intercept, we're going to set f of x equals 0. Let's Still, yeah, it's still visible to you. And then I'm going to solve. Okay, so negative square root of x minus 3 plus 5 equals 0. Okay, 5 equals the square root of x minus 3, and then, what's going on here? I'm going to square both sides, and then I add 3 to both sides, and I get x equals 28. All right, so check my answer because I squared both sides of the equation right there. 28 minus 3 is 25. The negative square root of 25 plus 5, yeah, that would equal 0. Okay. And then for the y-intercept, I'm going to have x equaling 0. F of 0 is going to be negative square root of 0 minus 3 plus 5. This is not a real number. Right, so this is negative square root of 3i plus 5. And yeah, it's not a real number, so I would say there's no y-intercept. So that would be interesting. Let's go and graph that and see what we see. I'm just going to go down here. All right, so the edge of the graph is going to happen at x equals 3 and y equals 5. So I need some first quadrant. So x equals 3 and y equals 5. Okay. And then it's a negative square root curve, so it's going to come down. Okay. We know that these square root curves, they kind of, if they go up, they increase and level off. This one's going to decrease and then level off. So I'm going to just kind of draw it like that. We found the x-intercept was 28, so we could probably label that. We're just drawing like this with no grid. Our graph is probably not drawn to scale, but this is a pretty decent sketch in my opinion. Also, yeah, notice there was no y-intercept because x equals 0 was outside of the domain. Okay. So that's what we're seeing. X is greater than or equal to 3, y is less than or equal to 5. Let's graph another one. Okay, this next one is the square root of 3 minus x. Okay, that's interesting. All right, well, for the domain, I just grabbed the interior, the radicand. I set that greater than or equal to 0. I forgot to make that plus and minus on the last problem, but then it didn't actually end up making a difference. Okay, so I'm going to add the x over here. I usually wouldn't do that, but then maybe switch it. So x is less than or equal to 3. That's my domain. For the range, okay, these square root things are always positive, so I'm going to say, okay, the square root of 3 minus x, that's a greater than or equal to 0 number. Okay, that's what I know for sure, but that's g of x, so I've got y is greater than or equal to 0. And then, what's next? X-intercept, y-intercept. So x-intercept happens when g of x equals 0. So that would be square root of 3 minus x equaling 0. I can see that's going to happen when x is equal to 3. You can square both sides and add. Just look at this. Let's see, what can we plug in there to make this thing 0? And that would be 3. For the y-intercept, I'm going to have g of 0. I'm going to plug in 0 for x and take the square root of 3 minus 0, and that's square root of 3. So that's y equals square root of 3. All right. And so but with these radical graphs, I really recommend just like, if it's a square root, start with the edge point, and then with cube root, start with kind of the center point, which I gotta think, yeah, is the next one. And then we're just gonna go from there. So 3, 0 is the edge of the graph. 3 zeros on the x-axis. So I'm just gonna point it right there. And then think about the domain, like which direction is it gonna go? Well, x is less than or equal to 3. And say, since x is less than or equal to 3, or we're seeing that negative x on the inside of the square root, we know it's going to go backwards. Okay, so and that looks like a pretty good sketch to me. And then we're going to need to put in y-axis. Okay, we're seeing that x-intercept right there. I already kind of did that. Y-axis, I guess that would be, maybe I'll put it here. And the y-intercept would be y equals square root of 3. All right, that's going to be a sketch. That's a pretty good sketch. It'd be even better if I label my axes, but I've been really bad about that this year. I think it's because I need to teach Algebra 1 again or something. So, C, cube root, great, that's what we need. All right, so let's do a quick cube root of x plus 3 minus 5. All right. So. Okay. Now the good thing about the cube root functions is the domain and range questions, they're so easy. Just respond all real numbers. Okay, whoops, I forgot to say all real numbers, but domain, all real numbers, range, all real numbers. Okay, but what we're going to need to do is find the center of the graph. What I would call the center, the place where the graph goes temporarily vertical, or whatever you want to call it. And that happens when you're taking the cube root of 0. So I'm going to grab the radicand and set it equal to 0. And okay, here I've got x equals -3. The y-coordinate would be h of -3 equals the cube root of 0, because that was kind of the whole point, minus 5, which is -5. So the center's at -3, -5. Oh, x-intercept, y-intercept, we can do that. I'll just go over here on the left. So for the x-intercept, that's going to be where y equals 0. So the cube root of x plus 3 minus 5 is equal to 0. Okay, so I'm going to add 5 to both sides. Cube both sides. 5 to the 3 is 125. So x is equal to 122. All right, then I'm going to have, what else am I going to have here? Oh, I need a y-intercept. X equals 122. That might not be something we can fit on our graph, right? And that would be okay. The y-intercept is going to be h of 0, which would be the cube root of 3 minus 5. Okay, now I don't know what the cube root of 3 minus 5 is, but I can tell that's going to be a negative number, because the cube root of 3, well, it's got to be less than 3, and 3 minus 5 is already negative, so this is going to be something pretty negative. But I've got all the pieces I need. It's time to draw a graph. So I think I'm going to start at the center, which is at -3, -5. It's over here in the third quadrant. I'm actually going to draw the graph first, and then, make the axes fit that. So I know the cube root's kind of like, in some sense, S-shaped. So I'm going to draw it like that, going temporarily vertical, and going off that way. All right, now, if this is -3, -5, this is in the third quadrant, to the left of the y-axis and below the x-axis. So I should probably draw my x and y-axis like this. And yeah, so the y-intercept, not going to be too negative, but the x-intercept being positive 122, probably not something I'm going to be able to see. And so I'm going to draw it like that. And maybe just label this as -3, -5. All right. And yeah, that's a cube root graph, but I think that'll be good for now. I've got a class coming in. I'll pick this up at lunch or something. All right, now D is the 3 times the square root of x plus 5. And so, I mean, I kind of think is like, okay, what is this 3 on the outside going to do to this? And it's going to just make it 3 times as tall. If you think about it, it's just the y coordinates getting multiplied by 3. But we're just going to do the same thing, as far as domain. I kind of, a few hours later, I'm forgetting what color I used for that. Domain was red. All right. Okay, so for domain, we're going to grab the radicand and set it greater than or equal to 0. So that's x plus 5 greater than or equal to 0. And then x is going to be greater than or equal to -5. And then the range, all right. I'm going to build this one up as if, like algebraically. But then I'll go and talk about it, verbally as well. Okay, so the square root of x plus 5. The square root of a thing is going to be greater than or equal to 0, regardless of what's inside. Okay, what's on the inside is x plus 5. That's not going to change the fact that the square root is going to either be positive or 0. If we multiply this by 3, we multiply both sides of the inequality by 3, that's not going to reverse the direction because 3 is not a negative number. It's not going to really do anything to 0 because 0 times 3 is still 0. So, and this is code for y. Okay, so y is greater than or equal to 0. Okay, so I've got domain, range. Let's do x-intercept. Okay, so that's where y equals 0. So I set 0 equals 3 square root of x plus 5. I forgot to go and talk about this verbally. Okay, so the square root of a thing is always positive, right? So 3 times the square root of a thing is similarly going to be positive. What determines the kind of the limit of the range is going to be any number that we have added or subtracted on the outside. Okay, so I'm over here. I'm solving for the X-Intercept. It's getting a little loud. Got a calculus class coming in. You know how that goes. So I'm dividing both sides by 3. Still 0. Okay. I'm going to square both sides, and 0 squared, still 0. And then we've got over here, x equals negative 5. Yep, that's still in my shot. Okay, and then, but we actually already knew that the point negative 5, 0 was on the graph because that was the edge of the graph, the end of the domain, and the end of the range. Okay, but okay, as for the y-intercept, I'm just going to plug in 0. And so y equals 3 times the square root of 0 plus 5, so 3 root 5. And so I'm going to sketch the graph. Okay. Going for the vertex or like the edge of the graph is going to be where x equals negative 5 and y equals 0. Okay, and then this is a positive square root graph. I mean, it's multiplied by 3, so it's going to be a little taller than usual, but it's going to increase and then level off. Okay, you can't see that, but I put an arrow there. I'm going to draw in an a y-axis here. Doesn't really matter where. Just as long as we're going to label our y-intercept with the value that we got, that's 3 square roots of 5.
Do you know how to do this one?
All right, I think that's all I'm going to be able to do before this calculus class gets too loud. They got a test today. They're high energy, you know. No. All right, I'll be back in an hour or two and keep working this. All right, next one's f of x is 5 minus the cube root of x minus 3. So we know what the domain is going to be because it's cube root. Domain and range are both going to be all real numbers. Just write that in real quick. Okay, for the x-intercept, we're going to set f of x equal to 0. So 5 minus the cube root of x minus 3 is equal to 0. Is this right? I feel like... Oh, okay, yeah. So this is going to be very related to the graph that we did in C. It's pretty similar. Okay. I was like, I feel like I've solved this equation today. And so I'm going to add the cube root to both sides. And cube both sides. Let's see. 125 equals x minus 3, making x equal to 128. Okay, for the y-intercept, we're going to plug in x equals 0. X equals 0. F of 0 is going to be y is 5 minus the cube root of negative 3. Right, yeah, because 0 minus 3. So that would be same as 5 plus the cube root of 3. That doesn't matter. I'm going to find the center point so I can start my graph there. And I'm going to say, all right, hey, here's the center. Okay, I take the radicand, I set it equals 0, because that's where I'm taking the cube root of 0. So x minus 3 equals 0, x equals 3. And f of 3 is going to be equal to 5 minus the cube root of 0. And that's going to be equal to 5. So 3, 5 is kind of the coordinates of the center. I'll just point that there. Okay. Now, this is a negative cube root. So it's going to open, or it's going to, open, but it's going to go the opposite of the way it usually does. So normally it would kind of be an S like that. It's going to be more like a Z here. Okay, so it's going to go down as I move left to right. And it'll go up as I move right to left. And that'll be, it's decent. All right, x-intercept's 128. That's going to be well beyond x equals 3, so I'm just going to put it kind of there, the x-axis, I'm saying. And the y-axis, that'll be to the left of x equals 3, because 3 is a positive number. And so I'm just going to draw in the axis there. And we can say that's 5 minus the cube root of negative 3. Okay, I'm just going to actually label it like that, and that'll be good enough for us. We're just reviewing. All right, problem F. Yeah, I feel like there's one. I should probably do another one after this. I'm going to do one more after this. Okay, so first thing, domain. It's a square root function, so we take the radicand, we set it greater than 0, so that's x greater than or equal to 0. The range, okay. The range is something like this. We are going to say, all right, well, the square root of x is always positive, so always not negative. It's greater than or equal to 0. At least 0 is what I've been saying today. So 3 times a number that's at least 0 is going to be at least 0, and g is going to be at least 0 plus 5. And g represents the y-coordinate, so that's why y is going to be greater than or equal to 5. If you wanted to build this up algebraically, what you would do is you would say, all right, the square root of x is greater than or equal to 0. Multiply both sides by 3, meaning, wait, I didn't just multiply both sides, I plugged in something. All right, that's more like it. And then what I really have is 3 root x plus 5, so I would add 5 to both sides. Okay. 3 root x, I did it again. 3 root x plus 5 is greater than or equal to 5. 3 root x plus 5, that's y, so y is greater than or equal to 5. Yeah, however you want it. Okay, for the x-intercept, that would be 3 square root of x plus 5 equals 0. So I would subtract 5 and divide by 3. So I'd say square root of x equals negative 5/3. And then we would subtract, or pardon me, we square both sides. Okay, finally, we've got one here that's going to pull back an extraneous solution. Okay, I'm going to square both sides, and I'm going to get x equals 25/9. But if you think about it, like, if I plug in 25/9, take the square root of it, it's a positive number. 3 times a positive number plus 5 is definitely positive. That's not going to be equal to 0. So this is an extraneous solution, and there are no x-intercepts. You know, we do need to be checking our answers when we square both sides of an equation, so I'm glad that happened at least once. All right, the y-intercept, that's going to be g of 0 equals 3 times the square root of 0, which will end up being 0, plus 5. Okay, it's going to be 5. Now I'm ready to sketch a graph. Okay. Now the edge of the domain is 0, 5. Okay, so we're going to say that's 5. We've got a positive square root scenario, 3 times the square root of x plus 5. Okay, so it's going to open up, and it's going to increase and then level off. Okay, so it's going to just kind of look like that. That wasn't a very good sketch. And if we felt like we had to label a second point, because, I don't know, maybe the instructions told us to label 2 points, or, you know, we just felt like we needed to for some sort of scale, you know, you could pick, I mean, any number you want that maybe that you could take the square root of. So maybe I've been choosing 1 a lot. Maybe I'll just choose 4, because I can take the square root of 4. 3 times 2 is 6, plus 5 is 11. And so, you know, if we gave ourselves a little more axis, labeled that, that would be 11. That would be our second point. And that's going to be a graph. Okay, let me cook up one more for us. All right, I think this one should be good. So this one's got a little something different. I've got, you know, the multipliers on the inside, not on the outside. That'll make a huge difference. And yeah, it's something different. So I'm going to solve for the domain. One more graph. I feel like, I don't know that we did enough graphs during the unit. So greater than or equal to 0, we're going to subtract 6, divide by 2, and we've got x greater than or equal to negative 3. For the range, okay, the square root's at least 0, so negative 4 plus at least 0, well, that's at least negative 4. But if that's not to your liking, we're going to start with the square root. The square root of anything is greater than or equal to 0, regardless of what's on the inside. So that would be 2x plus 6. We put that on the inside. We subtract 4 from both sides. And we've got, hey, this is our formula for y. Y is greater than or equal to negative 4. Now, since we've solved for the edge points of the domain and range, and this is a square root curve, we've kind of got the beginning of our graph. We know it's going to be at negative 3, negative 4. But we've still got a little bit more work to do. I'm going to find the x-intercept. That's where y equals 0. So square root of 2x plus 6 minus 4 is going to equal 0. I'm going to add 4 to both sides. Square both sides. Yep, still my shot. Subtract 6. Oh, this one worked out nice. And solve for x. X is equal to 5. Okay. For the y-intercept, I see what the catch is going to be. I'm not going to have any room to draw the graph. Okay, the y-intercept, that's going to be where x equals 0 and y will equal square root of 2 times 0 plus 6 minus 4. So y is going to equal root 6 minus 4. Okay, now, when we're going to draw the picture of this, it's kind of like, oh, is this a positive or a negative number? Well, the square root of 6, I know that that's less than 4, because 4 is the square root of 16, right? In fact, square root of 6 is going to be less than 3, because 3 is the square root of 9. Okay, so I know that this is a negative number. I'm going to grab a Post-it note and probably, I'll just sketch right down here. That'll be great. Okay, so my edge of my graph is going to be at the point where x is negative 3 and y is negative 4. I need some bit in the positive x direction, because we're seeing x equals 5 is going to be an intercept. So I'm going to go over here to x equals negative 3, y equals negative 4. Maybe it looks like that. Okay. And we know that the x-intercept is x equals 5. So I'm just going to kind of draw one of these things that's increasing and then leveling off. And wherever it intersects, I'm just going to make that equal to where I think x equals 5 is. And wherever it intersects the y-axis, I'm going to label that as root 6 minus 4. So I'm going to go over here, and I'm going to make myself, it's increasing but leveling off, or you can think of it as a sideways parabola, same thing. And so there I've got, here's x equals 5, and there is going to be the square root of 6 minus 4. And that's going to be enough graphs for us, right? If you've done all these, that's enough reviewing of your graphing. If you were with me on all of those, you should be with me on all the ones on the test, I hope. So now we're going to find the value of these expressions. And this is a lot of fraction exponents, and that's exactly what you need, in my opinion. So, there's 12 of these. Let's just get to it. All right. 16 to the 1/4 equals the 4th root of 16. It's a number that if I take it to the 4th power, I get 16. That's 2. For B, 64 to the 3/4 equals the 4th root of 64 cubed. I think that was supposed to be 64 to the 4th third. Let me think about this. Yeah, I don't know a 4th root of 64, because to take a 4th root, you take the square root, and then you take the square root again. So it's like square root of 8. But what I'm going to do is I'm going to simplify. I'm going to work the problem as it was written. And I'm going to have, okay, the 4th root of 64 is the square root of 8, because the square root of 64 is 8, and then the square root of that is the square root of 8. And that's what a 4th root is, the square root of the square root. So it's square root of 8 cubed. We could write that as 8 to the 3/2 power. And if you wanted to stop there, I guess that would be fine. But I'm looking for the value of the expression, so I'm going to kind of take it a little farther. Square root of 8 3 times is root 8, root 8, root 8. Okay. Put those together and make an 8, right? So I have 8 root 8. But simplified radical form, square root of 8 is 2 root 2, right? Because it's 4 times 2 inside the radical. So 2 root 2 times 8 would be 16 square root of 2. I think I typed that up wrong. I definitely did not intend for you to have to do anything like that. It was supposed to be cube root of 64 taken to the 4th power. Yeah. But it's all right. So it would have been 4/3 power. Sorry, these are mistakes we make. So 49 to the 1/2 equals the square root of 49. That's 1/2 power. And that's going to be 7. That's an essential one. 25 to the negative 1/2. Well, maybe I'll deal with the negative exponent first. That's 1 over 25 to the 1/2, which is 1 over the square root of 25, and that's 1/5. E is 16 to the 3/2. And that's going to be, well, the square root of 16 cubed, which is going to be 4 to the 3rd, which is 64. All right, I lost myself. Oh, that was 16 to the 3/2. All right, so F is the next one. 1/8 to the negative 4/3. Okay. I think I'll deal with the negative exponent part last. That's the cube root of 1/8 taken to the negative 4th. Okay. Well, the cube root of 1/8 is going to be a half, because it's the cube root of 1 divided by the cube root of 8. So it's going to be 1/2 to the -4th, which is, you know, I could flip the fraction to deal with the negativity and make that to the, you know, it's going to be 16. But if you wanted to say that's 1 over 1/2 to the 4th, that would be 1 over 1/16, and that's the same as 1/16, or as 16. Doesn't matter. All right, G is 27 to the 5/3. So I'm going to take the cube root of 27. I'm going to take that to the 5th power. That's going to be 3 to the 5, which, okay, I'm going to consult with my power table over there. That's, can't really see. I think it's going to be 243. Okay, but wait, I've got this. 3 to the 4 is 81. 81 times 3, 80 times 3 is 240, and then the extra 3, that's 243. Yeah, I've got that. Okay, I'm gonna just pull the problem set. H is, what is H? 100 to the -1/3. That was supposed to be 1,000 to the -1/3. I'm just doing 1,000. So you know how to take the cube root of 100. It's not a cube number. And it doesn't have any cube factors either, because 8, 27, and 64 do not divide 100, so I'm switching this. Okay, so maybe I'll do this one differently from how I did that one, right? I don't know what I'm saying here. All right, I'm going to take the cube root of 1,000. That's the 1/3 power, and then I'm going to take it to the negative first. The cube root of 1,000, that's 10, because 10 to the 3 is 1,000. And I'll say that's 10 to the -1, which is 1 over 10. Okay, you could have looked at this as 1 over the cube root of 1,000 as well from the beginning. It always kind of works out the same. I is -8 to the 4/3 power. Yeah, I just added the second because, wait, I is not -8 to the 4/3. That's J. Let me fix that. All right, it says -25 to the 4/3, but it definitely needed to be -125 to the 4/3 because, again, we don't know a cube root of 25. I don't know what I was thinking here. I think I made this in a hurry. So, but what I was really getting at with I, J, K, those three, is like, what do we do with the negative? Like what's going on here? Like, if there's a negative on the inside, negative on the outside, we need to be reminded about how that works. Okay, so I think the first thing I've been reminding a lot of people in all of my classes about PEMDAS lately, you know? And in this case, what we need is the M in PEMDAS, exponents before multiplication by -1. Okay, and this is very subtle. You know, there's not any grouping symbols here, right? We could put the parentheses around the 125 to the 4/3. But we do exponents before multiplication in PEMDAS, and this negative, that's multiplication by -1. So I'm going to say that that's the negative of the cube root of 125 taken to the 4th. Again, exponents before multiplication by -1. Cube root of 125 is 5. Okay. 5 to the 4 is 25 times 25. And I don't know about you, but I know that if I've got 25 quarters, that's $6.25. So 25 times 25 is $6.25. And then I multiply by -1 after the fact. That's I. Okay. With J, J was -8 to the 4/3 power. With the parentheses around the -8. Okay. So I could look at this as the cube root of -8, then taken to the 4th power. Right, because I don't know what 8 to the 4th is, and I certainly don't know what the cube root of that result would be. That's not going to work out for me. So the cube root of -8 is -2. Take that to the 4th power, and that gets you positive 16. And with K, it's going to be -9 to the 3/2. Okay, good. I'm glad I got one of these on here. Okay, so I'm going to kind of approach this the same way. 1/2 power is the square root, so it's the square root of -9 taken to the 3rd power. Now this one is out of bounds for, say, the upcoming test, but I wanted to remind you about this, right? Because if I take the square root of -9, I get 3i. And then I will get, over here, if I take 3i and I cube it, well, I'll have 3 to the 3rd is 27 times I cubed. And I know it's been a while, but not that long, right? We simplified I to the 3. We said that's I squared times an additional I, and I squared is negative 1. So I've got negative 27I. But again, just to emphasize, you will not have to be doing that on the test, right? There's not any complex numbers on the test. All right, this last one is 2 to the 3 halves times 5 to the 3 halves divided by 90 to the 3 halves. Okay, this is a different looking problem. This looks very different from even the rest of them. I must have had a reason that I put this on the review, right? It didn't just come out of no, I didn't just make this up. So what we're going to do here, I don't know how to take 2 to the 3 halves power. I don't know how to take any of these things to the 3 halves power. I know about 9 to the 3 halves power, but that's it. And I don't even have really 9. I have 90. So what I'm going to do is I'm going to combine all these. I kind of undo the exponent property that we're seeing here, where I'm just kind of going to call this 2 times 5 to 90 all taken to the 3 halves power. And that's going to unlock this problem for us because this is 10 over 90. That's 1/9. Okay. 3 halves power, we're going to square root first, and then we're going to cube. The square root of 1/9 is going to be 1/3 because it's the square root of 1 divided by the square root of 9. And, okay, 1/3 cubed, that's going to be 1 over 27. Okay, that was a lot of simplification, but that was exactly what you needed. Like, that's very, very classic traditional algebra 2 right there. All right, now we're going to find values of x that make these equations true. So we're going to be solving equations and checking our answers for extraneous solutions. Okay, hold that off to the side. And, yeah, all right. For A, square root of 2x plus 13 equals x plus 5. Okay, I'm going to square both sides. So if I square the square root, I'll get 2x plus 13. If I square x plus 5, I'm going to have to distribute. So I'll just kind of write this out to give myself some scaffolding here. Okay, it's going to be x squared plus 5x plus 5x is 10x plus 25. And then I'm going to set this thing equal to 0 because I've got different powers of x, and if I've got different powers of x in an equation and I want to solve it, I have to set it equal to 0. So x squared plus 8x, if I subtract 13, that would be plus 12. Okay, this looks like something that I could probably factor. Factors things that multiply to 12 and add to 8. That would be 6 and 2. So x plus 6 multiplied by x plus 2. And so that gives me x equals -6 and x equals -2. And I'm not just going to toss both of these out because they're negative numbers. That's not going to be how it works. Right? We need to check against the original equation. When I plug in x equals -6, I'm not liking this because I'm seeing -1 equals the square root, and that's not going to happen. So I know that's going to be an extraneous solution. But what happens is I've got -12 plus 13. That's the square root of 1 equals -1. No, square root of 1 equals +1. That one's out. But I need to check this one as well. When I plug in -2, I'm going to be subtracting 4 from 13, so that's 9. Okay, you take the square root of 9 is 3. 3 equals 3. Okay, great. That's going to be my solution. Okay, for B, we've got, oh man, I'm starting you off with all of the robust ones. Square root of x plus 2 minus 7 equals the square root of x plus 9. Oh, yeah, I remember that one. Copied this one off the internet. This one better work out right. Else I'm going to be pretty upset. Okay, so I'm going to square both sides. On the right side, I'm going to get x plus 9. And on the left side, I'm going to have to put in the work. So square root x plus 2 minus 7 times square root x plus 2 minus 7 is what I'm doing over here. And that's going to give me, well, just x plus 2 when I multiply those square roots. Minus 7 more is minus 14 of the square root of x plus 2 plus 49. And that's going to equal, well, let's square the right side. I'm just going to get x plus 9. Okay, now at this point, I'm going to kind of combine like terms. Oh, okay, this is actually not that bad, but at the same time, I'm not liking it either. I like the ones where we have a different number of x's, so when we go and, like the one in the notes, but it looks like that's not how this one's going to play out. So x plus 2 plus 49 is, I'm going to just call this negative 14 square root of x plus 2 equals, that's not what I wanted, plus x plus 50. That's better. And so I'm going to solve this thing by, I guess, subtracting x from both sides. Okay, that'll just like kind of kill each other off. Then subtract 51 from both sides, and I'll get 9 minus 51 would be negative 40. Oh, and hey, 14 divides 42, so that's a good sign. I feel like that means I'm on the right track. Okay, so I'm going to divide 42 by 14, and that's going to give me 3. So I've got square root of x plus 2 equals 3. Now I'm going to square both sides again. I'll get x plus 2 equals 9. And I'll subtract 2 from both sides, and I'll get x equals 7. But since I squared both sides of this equation twice, I should probably check my answer, right? Even if you only square it once, you need to check your answer for extraneous solutions. So the square root of 9 minus 7 is 2. 9 minus 7 is... No, pardon me. 3... Yeah, because the square root of 9 is 3. 3 minus 7 is negative 4. Equals the square root of x plus 9 is the square root of 16 is not equal to negative 4. Yeah, it's positive 4. So this one is extraneous. Okay? It does not work. This equation, I think, has no solution. Let me tell you a little something more about this, because somebody asked me a question in one of my sections that just I forgot about until now. All right, now, I think it was in my second period class. I had somebody ask me about the relationship between extraneous roots and like the graph or whatever, and I had told that person I was going to come back and give more explanation. I don't think I did. So what I want to do is I want to show you like what's going on here. I'm going to graph the left side as y1, the right side is y2, and then I'm going to zoom to the standard window. And okay, there we go. See, these things are never intersecting. Okay, that's pretty much what's going on. I think we were talking about in my class about square root equaled like some number of x's plus something else, and one was true and one wasn't, and that would just be where, just ran into one time or so. I forget, but that's something you could do to, get more analysis on what's going on here. If we, were solving something algebraically, we weren't really totally seeing what was going on. We could graph the thing and approach it from a different perspective and see what there was to see. And I think there was something good to see there. Those graphs, they're not going to intersect. Okay. Anyway, let's keep it moving. That's only B. I've got a lot more in 52 minutes in. So for C, y'all thought I saw people in my class say, the review is only one sheet. It's going to be really short, right? And that's not the case. Okay, square root of x plus 30, but maybe it's about to speed up, Maybe I've just done all of the slow ones up to now, and it's about to get really fast. Okay, I'm going to square both sides. Okay, x plus 30 equals x squared. Okay, square the square root, square x. Okay, multiple different powers of x in the same equation, got to set it equal to 0. Okay. I'm going to factor, because two numbers that multiply to negative 30 while adding to negative 1 would be negative 6 and positive 5. Okay, so that's going to give me x equals 6 and x equals negative 5. But, because I squared both sides of this equation here, I need to check my answer. Negative 5 is not looking promising because the square root of 25 is not negative 5. It's positive 5. But the square root of 36 is equal to 6, so I'm feeling good about that solution. I'm liking it. I'm moving on. All right, D. That's got some cube roots in it. Okay, I'm not scared of that. We can cube both sides just like we can square both sides. Okay, for D, it's going to be 4 times the cube root of x minus 3 plus 4 equals negative 16. Okay, well, kind of reverse order of operations. I want to isolate the radical. I'm going to get rid of that plus 4 that's attached first. So I'm going to subtract 4 from both sides. It was cube root x minus 3. Okay, just making sure. Is equal to negative 20 when I subtract 4 over there. Now I'm going to divide by 4. And I'll get negative 5. And now I've got the radical isolated. I'm going to have to the appropriate power. That's going to be cubing both sides to get rid of the cube root. So x minus 3 is negative 5 to the third, which would be, okay, 5 to the third is 125. A negative number cubed is negative. And then, okay, if I've got x minus 3 equals negative 125, I'm going to add 3 to both sides, and I'll get x equals negative 122. All right. Then for E, 2 times x plus 1 to the 4/3. Okay, so we've got some with a fraction exponent. 4/3 plus 1 equaling 33. Okay. Now I'm going to subtract 1. Divide by 2. And then I'm going to take both sides to the 3/4 power, because this is basically the radical. I've got it isolated. All right. Now, so 16 to the 3/4. Now that's going to be the 4th root of 16 cubed. But since I took the 4th root of both sides of an equation, I need the plus or minus. All right, so this is going to be plus or minus. The 4th root of 16 is 2, and 2 to the 3rd is 8. I'm going to say, all right, x plus 1 equals plus or minus 8, which is telling me if I solve for x, x will equal -1 plus or minus 8. Then I'm going to say, okay, well, -1 plus 8 would be 7. And -1 minus 8 is -9. And think about, what did I do to both sides of this equation? I took the 4th root and cubed it. Nowhere in there did I square both sides of the equation. I'm not needing to worry about extraneous solutions. Yeah, because 8 and -8 to the 4/3 power both come back 16, which is why we got the square root in the first place. I mean, pardon me, not the square root, the plus minus. But, okay, let's keep it going. F is 3x to the 2/5 power minus 2 equals 14. Yeah, okay, this one won't work. All right, so I'm going to start by adding 2 to both sides. Then I'm going to take both sides to the reciprocal power, which is going to be the 5/2 power. So I'm going to take 3x, and that's going to be equal to 16 to the 5/2. And that's equal to the square root of 16 taken to the 5th power. But wait a second, if I took both sides to the 5/2 power, I took the square root of both sides and then took that to the 5th power. So if I take the square root of both sides of an equation, that will cause me to need to remember a plus or minus. So I've got square root of 16 is 4, 4 to the 5. Okay, I don't think we've done 4 to the 5 in this class yet, but I see what the value of it is on my power table, or my, the analog calculator that I've got posted on my wall that you can't see. Okay, what you would say, okay, a power of 4 is also a power of 2. 4 is 2 squared to the 5, so that's 2 to the 10. And you could look on the analog calculator that's posted on my wall in my classroom, or you could do some finger counting. This is some arithmetic that we have to do in AP Calculus, 2 to the 10. 2, 4, 8, 16, 32. 64, 128, 256, 512, 1024. That's 10 powers of 2. Whoops, forgot the plus or minus there. And so really I've got 3x equals plus or minus 1024. So I could solve for x by saying x is plus or minus 1024 divided by 3. And maybe you're like me, you're like, hey, can I simplify? Quick way to check if a number is divisible by 3 is add up the digits. And if the digits add to a multiple of 3, then that number itself will be divisible by 3. So 1 plus 2 is 3, plus 4 is 7. 7 is not divisible by 3, so I can't simplify this. And that's going to be my answer. Okay, I did not square both sides of this equation, so I don't need to check my answer for extraneous solutions. All right, number 6, solve the inequality. And man, I get out of here before the parking lot gets too jammed, but the only way to do that is going to be just start working these inequalities. So -3 plus the square root of 3x plus 9 is less than or equal to 8. Okay, I'm going to add 3 to both sides. Square root of 3x plus 9 is less than or equal to 11. What we do is we solve it like it's an equation, and then afterwards we consider the radicand. So I'm going to go over here. I'm going to square both sides. 3x plus 9 less than or equal to 121. Because 11 times 11, that's 121. I'm going to subtract 9, and I'm going to get 3x less than or equal to 112. And 112 is very divisible, but not divisible by 3. Okay, again, same trick. 1 plus 1 plus 2 is 4. That is not divisible by 3, so I'm going to say x is less than or equal to 112 over 3. All right, but now I need to consider the radicand, right? So I go over here, and I grab the thing on the inside of the radical because this was a square root inequality, which is, I believe, the only type. No, we've got some cube root inequalities. Definitely lied to you there then. And we're going to, verify the domain. And so that's what I'm going to go here, give myself a little bit of room right on top of it. 3x plus 9 needs to be greater than or equal to 0. So that's 3x greater than or equal to negative 9, x greater than or equal to negative 3. Okay, now both of these things need to be true. X needs to be less than 112 over 3 and also greater than or equal to negative 3. So I'm going to kind of combine these into a compound inequality and say negative 3 less than or equal to x less than or equal to 112 over 3. But if you wanted to write this as an interval, you could say negative 3 to 112 over 3 like that, including both endpoints, showing that by using a square bracket. Okay, 6b. Okay, 6b is 2 minus the cube root of x is greater than 0. So that's when 2 is greater than the cube root of x, cube both sides, and that's when 8 is greater than x. Let's just think about this for a second. Yeah. So x is less than 8, right? If x went bigger than 8, cube root of x would go bigger than 2, and this inequality would not be true. Okay, so I'm feeling pretty good about this one. And I don't need to consider the radicand on this one because there's no domain issues on a cube root function. Okay, that was nice and quick. Let's do 6c. Square root of 2 minus x. Okay, yeah, we didn't do one like this in class, and I don't think you should really need to worry about this. But this is good algebra here. It's going to be nice. I like how this one's going to go. So, radical already isolated. Square both sides. So 2 minus x less than 9. That's not supposed to be less than or equal to. That was just a straight mark. I'm going to, I guess, subtract 2 from both sides. Divide by negative 1. That will reverse the direction of the inequality. And I've got x is greater than negative 7, but I'm dealing with a square root situation. So I'm going to need to grab the radicand and make sure that I am only considering places where the radicand is not negative. Okay, so I'm going to say 2 minus x greater than or equal to 0. So that's where 2 is greater than or equal to x. So x is less than or equal to 2. Well, if x is greater than negative 7 and less than or equal to 2, and if you've got to draw this out on a number line, don't be scared, right? Greater than negative 7 while also less than 2, that's going to be in here. Okay, that's just not going to be a good enough answer for you to get full credit on a test or something. We need to either write this as an inequality or as an interval. Okay, but that was 6c. Let's do one. All right, so 1 plus 2 times the cube root of x plus 4 is greater than 5. So let's subtract 1, divide by 2, cube both sides, subtract 4. Be happy, right? We don't need to consider the radicand for a cube root inequality. Okay, and probably past that, we won't be solving any cube root inequalities in my class for the rest of the year. All right, now we're going to find the area of x, or find the value of x with some applied geometry problems. Okay, so square root of 12, x, and area is 4 root 3. Okay, so that means that x times the square root of 12, that's going to equal the area, base times height. And that's going to be 4 square root 3. But I'm going to solve for x by dividing both sides by the square root of 12. And if you wanted to simplify this by making this a square root of 3/12, that might actually be the way to go. But what I'm going to do is I'm going to simplify the square root of 12. Okay, so 4 root 3 over square root of 12 is square root of 4 times square root of 3. Yeah, because I saw that and I wanted to cancel these off. Okay, and 4 over the square root of 4, well, that's 4 over 2, and that's just 2. Okay, so that's the value of x is going to be 2. For part B of this problem was a right triangle where this is 5, this is the square root of 7, and this is x. I would pay close attention to these geometry problems because I didn't just like do them because I like geometry. Okay, I've got 5 squared plus the square root of 7 squared equals x squared. So 25 and 7 is equal to x squared. I like this bringing us all the way back around to simplified radical form. So 32 equals x squared. Because x is the hypotenuse of a right triangle, we're going to probably just assume it's a positive number, right? I'm going to say x is equal to the positive square root of 32. And this is something that I can factor. It's got a square number that divides it, 16. Okay, I was thinking 4, but it's 16 square root of 2. So it's going to be x equaling 4 root 2. Okay. And we've got one more problem on this review. This was a real marathon. I started this really early this morning when I got into school, and it is pretty much time for the kids to be let out. So I'm going to go over here and say, all right, we've got some sort of triangle. It looks a little squarer, but it doesn't really matter how we draw our diagram. And this is 5. That's 10. This is x. Still the same principle applies. I just figured it might have been a while since you'd done a Pythagorean theorem problem where you had to solve for a leg where you were given the other leg and the hypotenuse. Okay, but again, we'll just do some simplified radical form practice. So x squared plus 5 squared equals 10 squared. So x squared plus 25 equals 100, meaning x squared equals 75, and x, being a leg of a triangle, at this point we're going to assume that means x is positive. That's going to be positive square root of 75. But 75's got that 25 factor, and we know 25 is a square number, so there we're going to go. 5 square root 3. Okay, that's going to be all. Okay, now I'm going to make sure to put a very clear note on the review Google Doc page, and I'm also reminding you right now, I hope you didn't just do an hour and 7 minutes worth of work cramming your answers into here on this page. If that's what you did, that's not going to go well. I was very clear in class, I will not take this sheet of paper back from you. Okay? All of this work has to be done on a separate sheet of paper. Okay? We were trying to conserve paper by running the copies, or I was trying to conserve paper by running the copies on the front side of the sheet. That's why there's calculus work on the back. And so you need to just use a scratch piece of paper. And if you don't have any paper, come see me. I've got to give you some. But that's all for this video. Thanks for watching. I really hope this helped.